pre-retrofit, and this is what you get, right? So look at it. How much we affected the peak flow? Quite substantially. The colors are kind of close, but you see that the magenta is the underdrain for the case with stormwater control measure, and then the brown is the pre-retrofit. Okay. Any questions to this one? So what I'm going to do is that I'm going to add soil. Okay, I'm going to allow infiltration, right? So so we have the pond. Let's say the groundwater is a certain depth, right? So what I'm going to do is that I'm going to add some soil layers, and then let infiltration also take place. Okay, to remove water from the pond, right? So so this is the thing. I need a few things to do that. Basically, if you have a groundwater depth, I'm going to say the groundwater depth is actually 1.5 meters below the pond bottom, right? So let's say the groundwater depth is 1.5 meters below the bottom of the pond. The bottom of the pond was minus 1.2, so I'm not going to go another 1.5 meters down, and that's going to be my groundwater depth. I'm going to use 3 soil layers, right? You can discretize it in any way. I mean, if you want to do it really precisely, or you're you know you have an interest in having a high resolution and so on, you can do 10 layers or something. I'm just going to go with 3 layers, right? Each of them will be 1.5. I'm sorry. Each of them will be 1.5 meters. Okay. Then we need the soil parameter. So it's basically, it uses Van Genuchten soil data. So basically, I just used, this is just some values for a certain type of soil, right? The K-sat actually is quite small. It's 1 times 10 minus 7 meters per second, or 8.64 times 7 minus 3 per day. And then you need a saturated moisture content of soil, residual moisture content. These two are Van Genuchten parameters. How many of you are familiar with the Van Genuchten model? Okay, great. Some people are. Anyways, it just gives us the 2 things: the relationship between the hydraulic essentially metric potential and moisture content, and it also gives us the relationship between the effective hydraulic conductivity and moisture content again. Something like. Anyways, but you can go to if you Google Van Genuchten parameter for a certain soil type, right? You're going to get a lot of tools. You're going to get a lot of information on the web about what, for example, sandy loam. What's the parameter for sandy loam? For hydraulic conductivity, you're going to get a very large range, right? Because the hydraulic conductivity, you have a lot of uncertainty. The variability is actually a lot. But for other ones, you can get narrower ranges, right? But these are N and alpha. These are Van Genuchten parameters. I'm going to show you another tool that you can get that too, by the way. There are codes outside too that you can actually give the soil texture data in terms of what the percentage of clay, sand, and silt, and maybe organic matter and so on, and it'll give you some numbers. Anyways, so what I'm going to do is that, by the way, we need to also assume an effective area of the infiltration. So I have this soil. I want to see how big these soil layers are in terms of their extent, the horizontal extent, right? So I'm going to assume that the effective area, actually from the rating curve, I can say the effective area comes from this equation, and I'm going to assume that it's actually operating depth is, let's say, 1 meter. So I'm going to calculate the area that way. So my area comes out to be 1,000 square meters. Okay, that's going to be the area of the soil that is going to be involved in infiltration underneath the pond, right? So you got to get it. Anyway, so that's what I have. So let's do. By the way, okay. So here's the thing. So I have 3 soil layers. Look. So what I got to do is I can do 2 things. I can just create 1 soil layer, make a copy twice, and then just change the bottom elevation, right? It doesn't take that long to do it, right? Because I'm dealing with just 3 soil layers. But you may want to make a model that has, I don't know, you may want to discretize your your stream river to 20 segments, right, or 100 segments, or you may want to discretize your soil into 20 layers to the groundwater, right? Then you don't want to copy paste 20 times and then go and change the numbers one by one, right? So this is there's a shortcut. So there's a way that actually there's this feature called create a 2D array. Okay, save everything. So create a 2D array, right? So this is for creating array of objects. I think it's nice to touch on this one too. So if I go here, again, you know, this graphical user interface doesn't know anything about what these components are. Okay, the code, this thing, it doesn't know one thing about what soil is, what precipitation is, what everything is reading from those JSON files, and then over there they're defined, right? So no discrimination. You can't really say, you know, do soil differently than something else. So here's the thing. What we say when I create a block, I say, okay, what are going to be the nodes, and then what are going to be the links, and then how many do I need, and then just create it for me, right? So basically, now in this case, I'm going to do, oh, I need to bring soils. I forgot one very important step. I haven't added my soil plugin yet, right? So I got to add my soil plugin. So I'm going to go back to preferences, add plugin, and then this time I'm going to add this one called unsaturated soil. Okay, so unsaturated soil, when I add it, I'll get a bunch of additional components here. This is variably saturated soil block, for example. This is the one that I use, and now I got a bunch of connections. So now I have a lot of components, by the way, right? Anyways, so now I'm going to go, now I have it and I can use it. So I go here to add objects, create 2D array. Then, so my block is going to be variably saturated soil block. So that's going to be just unsaturated soil. Then for the connection, I have two things. I have vertical soil to soil connector. So that's what I want, because these are soil layers. I mean, you can have a situation if you want to model soil in 2D or 3D, you're going to put them side by side as well, right? And then you have horizontal connectors too. But in this case, all I'm interested in just how water percolates down. So my connector is only vertical, right? So basically that's what I have. Block type, variable saturated soil block. Link type, vertical soil to soil collector. The number of grid cells in horizontal direction, all I have is 1, right? Because in horizontal direction, I just have 1. But in vertical direction, I'm going to do 3, okay? So now I got to be very careful. Then I do next. That's all I have. Then I go next, right? So next, I mean, it would have been easier for me to actually do the copy paste thing, but I just want to show this feature to you, just in case, you know. Anyways, so the saturated hydraulic conductivity, I need to enter that one. So here's what you see here. It may be a little confusing. So you have this value, right? And then we have a horizontal increment and a vertical increment. So what that is, let's say, just a very superficial imaginary case. Let's say I want to create a soil array, right? I know the topsoil hydraulic conductivity is something, but I want to increase it with a certain increment as I go downward, right? Which never happens in reality, but sometimes it's important. Sometimes it's useful. So basically, then what I've done is that my topsoil hydraulic conductivity is, I don't know, 1 meters per day. And then every time you go down, subtract 0.1. So the next one is going to be 0.9, 0.8, 0.7, so on, right? And why is that useful? I'll tell you in a second. Anyways, so basically, if you do a 2D array, basically you can do a horizontal increment and vertical. By the way, why do you think that's useful? Why such a thing to be able to increment things? Any guess? Okay, we'll see. But let's enter the numbers. I'll tell you. So basically, this is what I have. Hydraulic conductivity. I'm going to go with I can go with the 1 E minus 7, that's easier. So I'm going to do, oh, do I have it? You know what? I don't want to take a risk. I just want to do with 8.64 times 10 power minus 3 meters per day. 8.64 E minus 3 meters per day. And then I don't need to even look at this horizontal. I'm not incrementing it, right? So I'm not interested in that. Then the scale factor, don't worry about it. Okay. So in fact, actually, you can in OpenHydroQual anything that any parameter that you don't recognize, just don't use it. And for a variety of reasons, we've added some properties that have applications only specific projects and so on, and they don't apply to the general to everybody. But anyways, the hydraulic conductivity. So for example, this one, it says theta in EC equal to that thing. So this is OpenHydroQual has been used to interpret the ERT data, electric resistivity tomography data, right? So over there, you get electric conductivity of soil, not the moisture. So in order to do that, we need to create a link between moisture content and electric conductivity. And it's the power equation, and it looks like that. So if I assign some numbers here, OpenHydroQual is going to predict electric conductivity too. And then you can compare that with your measured electric conductivity, for example, and maybe calibrate your model or something like that. Anyways, so then this actual X and actual Y, these are for, you can actually use things like ParaView and so on to visualize. So those are that's for that. I'm not going to use it. Alpha parameter, we said it's actually going to be 0.1, 0.2. Okay, so we're going to use a 0.2 here. 0.2. The anisotropy ratio, that's if you have a 2D system and you have an anisotropic condition, so the hydraulic conductivity in X and Y directions are different. You can actually enter the anisotropic ratio. Bottom area, we decided to do 1,000, so I'm going to go with 1,000 square meters. Bottom elevation, okay, here is the thing. So bottom elevation, how am I going to do the bottom elevation? The bottom elevation is, I can tell what the bottom elevation of my topsoil is, but then my bottom elevation to the second one below is going to be different, right? So this is where the increment is going to come handy, okay? So here's what I'm going to do. Look, I can say the bottom elevation is actually what? The bottom of my pond was minus 1.2. Now I'm going to go down by another 0.5, right? So I'll get minus 1.7, right? So that's going to be minus 1.7, okay? Then I have the increment in Y vertical increment. That's all I need because I only move vertically. So here I'm going to enter a minus 0.5. How about that? So that the second soil block by, is going to just naturally, automatically go below the top one. Does that make sense what I'm doing? The numbers? Everything makes sense? Okay, so that's one thing. Then the Van Genuchten N parameter, let's see what that was, 1.25. So it's going to be 1.25. I think this is represented clay soil. Oh yeah, the depth of the soil block, I have to do that. That's 0.5, okay? So I got to make sure not to forget something because then I have to click on every single block. And you have specific storage, just keep the default. You can keep a lot of things as default. The initial moisture content, just want to keep it at 0.2. It's not given. So let's assume it's 0.2. It's going to only affect you at the beginning. Like initial condition is going to just affect, it's going to go away. The residual moisture content, it says 0.1 and then saturated moisture content 0.46. So I want to go back here twice. So the residual moisture content is going to be 0.1, and then the saturated moisture content is going to be 0.46. And by the way, look at this X and Y. I have the increments by automatic by default, right? So what it says is that the location is going to automatically shift to create an array, right? That's what I have, okay? I think, hopefully I'm all safe, okay? Yeah, let's see, next. Then you can change the name, but I don't want to change the name. And then there's no properties for the links, right? No properties. Sometimes in some areas you have to assign some properties to the links too. In this case, we don't have it. Done. So I got this one. The only thing is that they didn't end up at a good place, good location. Conflicts with matter. But I got the 3, right? You see that 3 blocks? Okay. So 1, I'm going to move them to the right place. And then let me just do a zoom extend. So that's what I got, right? So here's the thing. I created the 3 soil blocks, right? Now I need to do 2 things. First of all, I need to connect it to let the water from my, it's not connected to my pond. Okay, so I got to connect it to the pond so that I have infiltration from the pond. And then I need to also let the water to go somewhere, right? So my groundwater. So let's say I want to see how much groundwater recharge I'll get through this, right? And right, I need to do that because if I don't have a way to, for water to drain out somehow, this will get saturated pretty quickly. Soil will get saturated pretty quickly, and then you'll have no infiltration afterward, right? So 2 things. The first thing, I need to connect my pond to the soil. So what I use, there's this thing called surface water to soil connector, right? That's, there's another version too, but I don't need to use it. So I'm going to use just a regular surface water to soil connector. Then just connect this down to my soil. By the way, let me see if the properties are assigned correctly. So you see saturated hydraulic conductivity is the value that is assigned. Genuchten alpha parameter area. The elevation is, for the top one is minus 1.7. That's correct. The next one is minus 2.2. Okay, so 0.5 less than that. The third one is minus 2.7. Then I think the rest of it is fine. And then the residual moisture content, saturated moisture content, I should have an alpha too. The N, I'm sorry, N is going to be 1.25. So that's correct. For this one, it's always good practice to when you do a connector, you click on it to see if you need to assign any properties. But for this one, there's none. So that's one thing. It's done. I can actually run it right now. If I run it, what you'll see is that the soil will get saturated pretty quickly, the first event, and then you have no infiltration afterward, right? Because the water doesn't have anywhere to go. Then, so what I'm going to do is I'm going to use, again, I can use, actually, if I wanted to, let's say, see what the impact of these stormwater ponds on my regional groundwater is, right? I can actually use a groundwater block and then somehow build a groundwater model that is connected to these two, right? So that'll be a completely integrated system, right? I mean, it has its own challenges because, how many of these are you going to have and so on, what's the scale and those things, but you could do it. But right now, all I'm interested in is how much groundwater recharge do I get, how much water infiltrates, and then as soon as it enters the groundwater, I don't care about what happens to it afterward, right? So so basically, for that reason, I'm going to use another fixed head, right? I'm going to use another fixed head for the groundwater. So I'm going to add another fixed head. This is going to be my groundwater to make sure that it's, you can just go and change the name to, let's say, groundwater. Okay, so that's going to be my groundwater. The only property that I need to assign to this fixed head is going to be the head, right? So I said the groundwater table is 1.5 meters below the bottom of my pond, right? That means the head of the groundwater is going to be minus 2.7, right? So is that clear why it's minus 2.7? So basically, I will do the head. It's going to be minus 2.7 meters. And then I need to find a link to connect my soil to, by the way, I can just move this down here and then do another thing. Then there is, when I enter soil, you have this thing. It says soil to fixed head connector. You can have a soil fixed to head connector horizontal too, in case you have a boundary somehow, fixed boundary is horizontal. But in this case, it's vertical, is this one. So I'm going to use this one, connect my soil to the fixed head, click on it to make sure no properties. So I have no properties. And the name is assigned as this, basically the name of whatever you connect, dash, the name of whatever you connect to. That's it. You're all set, right? So we got a next version of the model with infiltration. Now I'm going to just run it. And let's look at the results. Let's see what we got done. So basically, I want to see how much infiltration I get. So this is the infiltration rate. So basically, if I click on this link, it gives me the flow. So I can look at the flow. This is the flow. By the way, why do you think at the beginning it's high and then it's gradually gets smaller and smaller?
What was the question?
Why is it higher values at the beginning and then it gets smaller and smaller? Or smaller, but it gets a smaller value and then it stays kind of steady. Yeah, so my initial moisture content that I assigned was probably off. Okay, so it takes some time. So initial moisture content is low, which means that the matrix suction is going to be higher. So you have a higher hydraulic gradient between the pond and the soil, so you get higher flow, right? And then after time, it'll be. Let me test that hypothesis. So basically, I can look at the moisture content in this topsoil, for example, or the bottom one. I don't know. It doesn't matter. Let's do this one. I can look at the moisture content, and this is my moisture content. So it actually gets to, from 0.2, it gets to almost saturation. My porosity is 0.46, and it stays there. So it's underneath a pond, right? So it's basically almost always saturated. You can look at this, do the same thing for the topsoil. You have more kind of fluctuations because you're farther from the groundwater, but it's almost the same pattern, sort of, right? You can, okay, so that's, then, I don't know, you want to see the groundwater recharge rate. Look at the flow here, that's how much, so I got a negative, whenever I look at it, at the beginning I got a negative value, and then it became positive and stays sort of positive afterward. Why do I get a negative flow at the beginning? Any idea why do I get a negative value? Capillary, exactly. So basically, that's capillary fringe. I mean, I assigned a very unrealistic initial moisture content to the soil at the bottom, which is right at the groundwater, and basically sucks up the water from the groundwater, right? So the flow can go both ways. Okay, that's it. So okay, so that's and then I can look at, let's see if we get overflow again. So I can look at this. I assume maybe you don't get any overflow anymore. Oh, we still do. So the thing is that we get a smaller overflow. We still get an overflow. I mean, that event was probably very large, and then the hydraulic conductivity value that I assigned to my soil was quite low. So the infiltration is not that effective, right? So it doesn't eliminate my overflow entirely. Okay. Okay, let's move on. By the way, what if you have multiple sub-catchments? What if I have multiple sub-catchments? So basically what I'm going to do now is that I have one sub-catchment. Let's say I have two sub-catchments, and then you can go from there. You can have as many as you want, right? So what I'm going to do is that I have a catchment. Let's say I have two catchments. Catchment 2 upstream drains to catch basin 2. So I have a catch basin, and I have a catchment 1. It drains to catch basin 1, which I'm going to call CB1. And then CB2 drains to CB1 through a 500 meter sewer pipe. And then CB1 drains to pond through a 100 meter sewer pipe, right? Okay. So basically, now we need to have some constraints about the elevations and so on. So catchments, the elevation has to be higher than the catch basin inverts, and then it has to be higher than the pond bottom. So I have to pay attention to that. All links convey flow by gravity. So if we're going to have, so this is the diagram of what I'm going to do. So we have a catchment 1, it goes to a sub-catchment, and I have a sewer pipe, and then the catchment 2, and then, it goes to the pond. As I'm doing it, I may make mistakes in terms of numbers and so on, but that's all fine. We're going to run it. We'll see something doesn't make sense, and we'll see what number we have to change and things like that. So basically, okay, let's do it. By the way, I can keep catchment 2 because it's already, the parameters are this. So basically I already have this, right? So I need a catch basin and then another sub-catchment that I'm going to add. I can do that rather quickly. So basically this is my catchment 2 right now, right? Is that right? Because I call this sub-catchment 2, right? So basically, how about if I just go and change the name of this to sub-catchment 2, okay? Then to make, by the way, this has to go to a catch basin, so I can't have this link going directly to the pond, right? So I'm going to delete this. I'm going to delete this link, okay? Then I'm going to do two things. I'm going to actually make a copy of this because I have a lot of the properties are the same, right? Except for the area. Then I'm going to paste it. Okay, so let's see what the properties of that catchment 2 is. It says, it says nothing about, so I have the invert elevations and so on. It says nothing about the width, right? But presumably, if my catchment is smaller, my sub-catchment is smaller, the width also is smaller, right? So basically, we said the width of the flow is 100 meters for the sub-catchment 2. For this one, I don't know, it's probably smaller, but I'm just going to keep it the same, right? Or, let's just make it smaller. Let's make it 70, okay? Then, okay, so that's what we got. Then what I'm going to do is that I'm going to need to add 2 catch basins, right? So that these sub-catchments actually discharge to them, right? So let's do 2 sub-catchments. So where's my sub-catchment? It's actually right here. That's it, right? This is a catch. I'm sorry, catch basin. So I'm going to add 2 catch basins, 1, 2. Okay. So this is 1. This is 2. To make sure that everything is consistent with my. So this is going to be catch basin 1. I think that was in my diagram, and this is going to be my again. This is sub-catchment 1. Okay, so I'm going to call it SC1. And this is going to be catch basin 2. I'm going to call it CB2. Okay. Then let's assign some properties to the catch basin. So I'm going to say the base area is actually one square meter. The bottom elevation has to be high, right, compared to my pond so that I have downhill flow. So based on the diagram that I have here, it says the invert elevation is 2.5 meters. So it's going to be 2.5 above 0, right? Positive 2.5. So basically, this is going to, the bottom elevation is going to be 2.5. Oops. 2.5. Okay, that's all. That's, I think, all I need to do. And then this one, we said the bottom base area, again, I'm going to make it 1. And the bottom elevation, I'm going to make it 1.25, right? So basically, this diagram says 1.25. So I'm going to do 1.25, 1.25. And then let's just connect. So what I need to do is use the link from catchment. I'm going to connect this to the catch basin. Again, link connected to the catch basin. And then these two, I'm going to use a sewer pipe to connect them to each other. So use a sewer pipe. So this is a sewer pipe. Okay, this is a sewer pipe, you see. And then just connect it. Okay, oops. I think okay, so that's it. And then another sewer pipe to get the water from my downstream catch basin to the pond. Okay, and then I have some properties for the pond. The Manning roughness coefficient, do I have it here? I'm going to use the same parameters that I did for the other pipe, right? I had an underdrain pipe, so I'm going to say 4-inch. The Manning roughness is going to be 0.013. Okay, so basically this is going to be 0.013. The diameter is going to be 4 inches, so I'm going to just say 4-inch. And then the end, so the start elevation and end elevation. Well, pipe length, by the way, was 500, if you remember from the diagram. So it's going to be 500 meters. The start elevation is, let's do it the same as, I don't know, let's do it a little above this. So basically this is 2.5, I'm going to just go 2.6, right? So basically say 10 centimeters above the, so it's going to be 2.6, and then this is going to be 1.35, right? 1.35, okay? Then this one, Manning 0.013, diameter, I'm going to still do 4 inches. So it's a 4-inch pipe, and we'll see if 4 inches is enough or not. Then the pipe length was 100 meters. The start elevation, I'm going to do 1.35 again, or I don't know, 1.30, 1.35, doesn't matter. It's above the bottom. Let's do 1.30. And the end elevation, all I want is to be above my pond bottom elevation, which we set to be minus 1.2. Okay. So I'm going to do, I don't know, maybe minus 0.8, right? So basically the pipe doesn't necessarily go all the way to the bottom of my pond. It just stops at one point, right? So maybe minus 1.8 is enough. And that's all I have, right? So that's, now we got the system is a little more complicated. We have 2 sub-catchments, catch basins, things like that. Let's just run it. We have the soil and everything, right? So that's what we got. Now you can see, I don't know, I can look at the flow here. So that's the flow that I got into this pipe. You can look at the flow here. And then one thing is that design-wise, is it adequate? That 4-inch pipe is adequate or not? To find that out, I can actually, one thing I can look at is that I can look at the water head here, hydraulic head here. Doesn't make any sense, but I'm not going to fix it. So basically it's actually, I got 200 meters. So that means my pipe is not adequate. Okay, 4-inch pipe is not adequate. It doesn't drain. During one of the events, my head just went up. You know, this means flooding. You know, it's never, the water level obviously never gets to 201 meters. It just goes up and then your street gets flooded, right? So that's what it says. It's happening. But let's just see if I can fix it real quickly. So let's say you want to use this for design. Just going to do 8-inch. That may not be enough too. So I'm going to make this 8-inch and then maybe make this one 6 inches. So it's a 6-inch pipe. I don't think that's going to alleviate the problem completely, but it's going to probably make it a little better. Okay, done. Now let's see what happens. I guess you're going to get some better results, but probably not perfect. So I can do water depth. Now it's 19 meters. Still, my system is getting flooded once, right? But less than before. Does that make sense? Okay, so now let's do this. Let's do bioretention. Okay, how I'm going to do it? I'm not going to reuse these. I'm just going to start from scratch. So I'm going to now create a model of bioretention. A lot of things are similar. But what I do is I'm going to add an engineered soil layer with high hydraulic conductivity underneath the ponding area. And then I want to add an aggregate layer and then an underdrain pipe from the aggregate layer with maybe a riser to the outflow catch basin. So let's just start a new project. File, a new project. So let's see what we have for the bioretention. So now replace this. This is the properties that I'm going to use. Actually, this is it. This is my bioretention. I want to model this. So I'm going to assume that the ponding area, I'm going to set the elevation here. So the elevation of the ponding area is going to be 0. So we have a little ponding. We're going to have an overflow pipe, an underdrain pipe. It's going to be 4 inches. Aggregate storage, engineered soil. The elevations are given. And then I'm going to have a native soil, and I'm going to model groundwater recharge as well. You know how much water goes to the groundwater, and this is going to be groundwater table. Does that make sense? Everything clear? So let's get this started. Okay, let's see how quickly I can do this. Start from, I wish I had my, you know what? I changed my mind. I better use my, the model that I created a little bit, because you know, I can use a lot of things here. So let's just delete a bunch of things, because I don't have to then create my catchment and assign the properties and so on again. So let's delete this one too. I don't need this one. I can actually keep the soils. Okay, I'm going to reuse them. Then, you know, move these things away, and then at the end, I'm going to use it. Then let's just get, yeah, I don't need this. Delete that one too, and then delete this catch basin. By the way, whenever you delete a block, all the links connected to it are also deleted. Because you can't have a link just not connected to anything. Then, okay, so then what I'm going to do is that I will just connect my catchment to the pond. Now let's see what the properties are. Let's see what the pond is supposed to be. So basically, this is the facility plan area is 400 square meters. So now my pond is actually 400 square meters. The alpha, based on that area, the alpha and beta are going to be, oh, that's actually for the rear. I'm sorry, the S alpha relationship is going to be this one. So the alpha in the pond is going to be 666.467. I calculate that, and that'll give me, if you do, I don't know, it's based on an assumption. So if you have 20 centimeters of water, that's how the area is going to be 400 or something like that. So basically, let's say alpha is 666.67. Let me change that. So the alpha was, before it was 500, and now I'm going to do 666.67. By the way, you can actually, you know what, in reality, when it rains, it doesn't rain just on your catchment, it rains on your pond too, right? So it's up to you, but it's not going to be substantial, but you actually can apply the precipitation directly to the pond too, right? So, but it doesn't matter. But if you want to do it, let's just do it. Let's just do rain. Then, okay, so we have the pond. Everything's set with the pond. Now, let's say the weir. So what do you have for that one? We have alpha being 1.76 times 10^5, beta is 1.5, right? So let's change that one too. And then the crest elevation is going to be our overflow depth, right? So basically, I already know, based on this one, I know it's the crest elevation is going to be 0.3, right? So basically it says when the water level gets to 0.3, let it overflow, right? So basically the crest elevation is going to be 0.3, and this number is, what have we got here? 1.76 E5, 1.76 E5, 1.76 E5. Okay, so now we got the pond. Now I'm going to add actually one soil layer. So let's add just one soil layer underneath my pond, and this is going to be my engineered soil, right? So we can just name it engineered soil. Engineered soil, for example. Let's see what we know about the engineered soil. The engineered soil, I'm going to go with thickness is 0.6. What about Van Genuchten parameters? Just going to assign something, right? It should say somewhere, but anyways, I'm just going to assign some numbers. Oh yeah, here it is. Here it is. So so basically, this is going to be 0.6. Depth of the soil is going to be 0.6. The bottom elevation of this soil is going to be minus 0.6 because it's 0.6 below the zero, right? So this is going to be minus 0.6. The area, we said the area of facility is 400, so this is going to be 400 square meters. The Genuchten alpha and K sat and so on, I got to look. So let's say saturated hydraulic conductivity is this time 8.64. It's actually 1 times 10 to the power minus 4 meters per second, which is 8.64 meters per day. So now it's much higher, right? Because it's engineered soil. So 8.64. Then, okay, that's it. And then what do we have for alpha? Alpha is going to be 3.5, and it's going to be 1.7 for the bioretention media. 3.5, 1.7. So alpha is going to be Genuchten, and this is going to be 1.7. And then my alpha is going to be, what do we have? Short-term memory problem. 3.5. Okay. Is that all? I think this should be all. So we got everything set. And then residual moisture content, saturated moisture content, should I change it or not? 0.045, 0.43. So 0.045 is the residual, and then 0.43 is the saturated. Again, my initial is probably off, so that's one thing. Then what I'm going to do is that I will just add a surface water to soil connector to connect my pond to the engineered soil to let the infiltration happen. Okay, that's what we have. Then let's do the aggregate layer. Okay, so the aggregate layer, I'm going to actually use an aggregate layer. Look at this. There's an aggregate zone. Okay, so this aggregate zone. So let's just do that one. Then, so what is going to be the bottom elevation of the aggregate layer based on my diagram? It's basically 0.45 below my soil, right? So my soil was minus 0.6. This is going to be minus 105, right? So minus 105, 5 meters. The area of the facility is 400, so the area of this is also 400. Then the saturated hydraulic conductivity, I'm just going to leave it there because it doesn't matter. And then, all those things, I'm just going to keep them, right? Keep them as default. Then, so 2 things, soil to, so I have this connector called aggregate layer to soil. Here it is. Actually, I have a soil to aggregate layer vertical, so I'm going to use this one. I need to use this one. So I'm going to use soil to aggregate layer. Oops. Okay. And then I'm going to do, I need another one to connect to my bottom soil, right? So basically, I will use, there's another one called aggregate layer to soil link, okay? Then if you look at the icon, there's an aggregate layer and then a soil at the bottom. So then I'm going to do this. Oops. Come on. I need a mouse pad. Okay, that's it. And then I need to be careful about something. Just the bottom elevation is 1.05. So I need to change the bottom elevation, adjust the bottom elevations of my soil because this was based on my previous thing. So basically, so this is going to be minus, just trust me in my calculation. Or if you don't, let me know. So basically, it's going to be 1.55 because 1.05 and it went down 0.5, right? And then this one is going to be 2.05, 2.05. And then this one is going to be minus 2.55. And then if I want my groundwater to be 1.5 meters below my aggregate layer in this case, right? That's what the assumption is. This is going to be this is going to be the same as the bottom elevation of this one, so minus 2.55, right? But you get the idea. Good. Okay, under drain pipe. Let's do the under drain pipe. Actually, the way I'm representing it is like this. The overflow goes to my sewer directly, okay? And then the under drain will also go to my sewer directly. That's not the way bioretentions are typically designed. They are usually, basically the overflow goes to the same pipe, right? And then it goes to the catch basin. So if I want to model that, I need some sort of a junction, right? But I'm not going to do it, right? Basically, I'm going to keep it simple. So I could do it the more realistic way, okay? I needed a junction, right? But I'm not going to do the junction. I'm going to just say I have this pipe that separately goes to, from the aggregate zone, it goes to this one. And then let's see what parameters I have for it. It's a 4-inch pipe. It is, do I have a length for it here? 30-meter length, right? I think that's all I need. So basically, the manning roughness, just like other pipes, I'm going to make it 0.013. It's going to be a 4-inch pipe, so 4 inches. Then the start elevation and end elevation is important. My fixed head is minus 1.5. This is actually minus 1.05, right? So basically this one I'm going to do end elevation, let's say minus 1.4, right? Then the pipe length, we said, is what, 30 meters? Yeah, that was 30 meters. Then the start elevation minus, let's say it's a little above the bottom of the aggregate layer, which was minus 1.05. So let's say minus 0.95, right? So 10 centimeters above the bottom of your aggregate layer. That's it. This is the bioretention system. Any questions? So let's now run it, okay? Because I want to have some time for the water quality as well. Okay, that's it. So let's just see, okay, what's happening. Let's say the flow from our under drain. This is the flow rate from the under drain. Let's see if you had any overflow. No. Okay. So my under drain is enough, right? Or the parameters came out so that you didn't have any overflow in the 1 year simulation. Maybe if you do the 3-year simulation, you may get some overflow.